Hello dear students, welcome to the video tutorial on cryptography. So in this video we are going to talk about the Kerberos protocol. So we'll see the history of Kerberos, what is Kerberos, requirement of Kerberos, Kerberos terminology, working of Kerberos, is Kerberos symmetric or asymmetric, and is Kerberos safe or not. So this is the history of the Kerberos. So according to the Greek mythology, this many-headed dog, it is called as Kerberos. You can see here, this is having three heads, this dog, and these three heads represents three tasks of Kerberos. Okay, so this word Kerberos is taken from the Greek mythology, so it is nothing but the many-headed dog. So what is exactly the Kerberos here? And this is the symbol in the network security that we will use for Kerberos. So Kerberos is a network authentication protocol. This is very important. This is a protocol which helps you for the network authentication or authentication between the client and server. So that works on the basis of tickets to allow nodes communicating over non-secure network to prove their identity to one another in a secure manner. So consider there is a client and server who want to communicate over the non-secure communication network or non-secure channel. Then we can use for authentication, because server has to authenticate the client. Okay, whether this information is sent by the correct client or authorized client or not. So to check that, what server will do, server will implement Kerberos protocol, because it is there on the non-secure network. So it is better to implement Kerberos protocol on the server so that server can authenticate the client. And even we can implement this Kerberos on the client side to authenticate the server also. Okay, next. So what do the three heads of the Kerberos represents? As I said, three-headed, the dog picture. So three-headed means there are three steps actually. Three steps or security process in the authorization and authentication. These three steps we are using for authorization and authentication. So that three head indicates one is user, another one is KDC, that is key distribution service or key distribution center, and third one is the service server. So Kerberos is a standard feature of Windows software. So in Windows 10, we are using Kerberos 5 version 5 for the authentication and authorization. So it is already inbuilt feature in the all Windows software. Why Kerberos? So as we know that Kerberos are used for authorization and authentication. So Kerberos is an authentication protocol that is used to verify the identity of the user or host. The authentication is based on tickets used as a credential, allowing communication and proving identity in secure manner even over the non-secure network. This is what we have studied in the definition. Okay, on the non-secure communication channel or on the non-secure network where server wants to authenticate the client, where server want to check whether the information is sent by the authorized client or not. So in such cases, what server will do? Server will implement the Kerberos protocol, which helps the server for the authentication of client. Okay, so whenever we have non-secure network, to make the authentication between client and server, we are going to use the Kerberos protocol. So what are the requirements of Kerberos protocol? So there are four requirements: secure, reliable, transparent, and scalable. So what is secure? Kerberos should be strong enough that potential opponent does not find it to be the weak link. Okay, so what we require from the Kerberos is we require very much security from the Kerberos so that opponent can't find or opponent can't have this attack over the non-secure channel. So we need to have high security in the Kerberos. We also require reliability from the Kerberos. Okay, so that is consider if the link for all services, okay, So consider there is a link between client and server, and if this link is not available, or for by any means this service is not available between the client and server, we should have one backup server. Okay, so that whatever the client requires from the server, we can provide it through this server. Okay, so we have the system which is backup as a backup manner, that is called as reliability. You can see here, for all the services that rely on Kerberos for access control, lack of availability of Kerberos service means lack of availability of the supported services. Okay, so consider we have a system which relies on the Kerberos. Okay, if Kerberos is this, consider this server, Kerberos server is not providing me any service, then we should have the backup of the same server. Okay, where we can connect and we can communicate with them for the other matters like service, other supported services. So if one server is not working, we should have the backup with another server. That's what called as reliability. So we require transparent also. Ideally, the user should not be aware that authentication is taking place beyond the requirement to enter the password. So that's a transparent. Next, we also want the scalability from the Kerberos. So what is scalability here? So we know that a client wants to connect with the many number of server. So we should provide the scalability. Okay, we should not stick that it has to communicate with only this server or only 2 servers or only 3 servers. It is not like that. We should provide the large support so that the system or the client and server can communicate with each other. So this is what is called as scalable. So the system should be capable of supporting large number of client and server. We should not stick to only one client server or one client 2 server like this. Okay, we have to design a system in such a way that it has to support a large number of client and server. So there are certain terminologies that we are going to use in the Kerberos protocol. So you can see here the client, the key distribution center, which contains two more server within it. One is authentication server, another one is TGS. It is called as TGS, ticket granting server, and this is our server. Now always there should be the communication between client and server takes place, but before client should directly communicate with the server, first we need to authenticate the client. Okay, so for this authentication we are using Kerberos protocol. Okay, because we need to check whether this client is valid client or not, or whether he is a correct person or not who is sending the information. To authenticate that, we are using Kerberos protocol. Okay, and these all things are required in the Kerberos protocol. So what is this? First one, AS, authentication server. A server that issues ticket for a desired service, which are in turn given to the user for access to the service. Okay, so what authentication server will do? Authentication server will issue tickets to the user. See, first here client or user, he will send the login credential, his login credentials to the authentication server. Login credential means it contains the username, password, like this, all these things to the this authentication server. Authentication server, what it will do, it will take all this login information and it will send back the TGT. You can see here in the second step, TGT, ticket grant ticket. Okay, ticket granting ticket. Okay, so it will generate the ticket and it will send back that ticket to the client. That's what we are talking here. You can see here a server that issues the ticket for a desired service. So why client wants this service? Client wants to communicate with the server. To communicate with the server, client has to have the ticket from the AS, from the authentication server. Okay, so remember this point. Next, what is client here? So an entity on a network that receives the ticket from the Kerberos. That receives the ticket. It receives the ticket from the authentication server. This is called as client. What is credentials here? You can see here credentials. A temporary set of electronic credential that verifies the identity of the client for a particular service. It is also a ticket. Okay, so credentials are nothing but it is used to verify the identity of the client. That is called as a credential. So usually credentials means it is in terms of ID of the user, password of the user, all these things. We are calling it as credentials. Next is credential cache or ticket file. A file which contains the keys for encrypting communication between user and various network services. Okay, so ticket file or credential cache means it is a file which contains all types of key which is used for encrypting communication between user and various network services. Next, crypt hash, a one-way hash used to authenticate user. So it is a hash function. So we'll use hash function here, which will generate a hash code, and this hash code we will use to authenticate the user. Next, you can see here key. So data used when encrypting or decrypting other data. So we'll use the key when we want to encrypt or decrypt the other data. Next, KDC, you already know what is this. Key distribution center, a service that issue Kerberos ticket and which usually run on the same host as the ticket granting server. You can see here, this is the key distribution center which contains authentication server as well as the key granting ticket granting server. Next, realm, it is called as realm. Realm, a network that uses Kerberos composed of one or more server called as KDCs and potentially large number of clients. So in the realm, we are using more number of clients which are connected with the more number of KDCs. Next, TGS, that is ticket granting server. You can see here, a server that issues tickets for desired service which are in turn given to the user for access to those service. The TGS usually runs on the same host as the KDC. So TGS will be present in the same host where the KDC is present. So that means KDC, inside that it contains TGS. And last one is TGT. As I told, TGT, so it is ticket granting ticket, a special ticket that allows client to obtain additional tickets without applying for them from the KDC. You can see here in the third step, in the second step, TGT is there. TGT is nothing but ticket granting ticket. It is a special kind of ticket that allows the client to obtain the additional tickets. Okay, so without contacting this key distribution center, without applying for them from key distribution center. So these are the terminologies that we are going to use in the Kerberos protocol. So this is the working procedure of Kerberos protocol. You can see the first step in the figure. So here client, it is sending its user ID or it is sending some request to the authentication server. Okay, so you can see here authentication service verifies the user ID. So what authentication service will do? It will receive this user ID and it will verify the user ID of the client. This is the first step. So in the second step, you can see upon verification, a timestamp is created with the current time in the user session with the expiration date. So once that server verifies that whether user ID of the client, what it will do, it will generate the timestamp. TS is created with the current time. At what time it is generated, so that's called as current time. With the in the user session with expiration date. Along with that, we have expiration date. The timestamp ensure that when 8 hours is up, encryption key is useless. Means this timestamp, its validity is up to 8 hours. Once it crosses 8 hours, that means your encryption key becomes useless. This is the second step. So you can see here. So it is generating, this authentication server is generating TGT, ticket granting ticket. Along with that, it will generate a timestamp of 8 hours. Okay, so along with the expiration date, and it will be sent to the client. So what client will do, it will receive this TGT or ticket, and this TGT will be sent back to, you can see here, the key is sent back to the client from the TGT. Okay, so that key which is generated by authentication server, we are sending it back to the client. So now that means client has received that TGT. So in the fourth step, client will submit or client will send that TGT to the ticket granting server, TGS, for the authentication. In the fifth step, after receiving the TGT from the client, what this TGS will do is, it will encrypt that key. Okay, it will create an encrypted key with the timestamp which is given by the client. Client has given the timestamp, you can see here. The same timestamp, it will give it back to the client again. Okay, so along with that, it will give the encrypted key. So when this client receives that encrypted key, the client decrypts the ticket, because client has the ticket here. You can see here TGT is present with the client, ticket granting ticket, and that ticket will be decrypted by this key which has been sent by ticket granting server, and sends the acknowledgement to TGS. Once it will decrypt that ticket, it will send the acknowledgement to TGS. You can see in the next step, you can see here. So client sends its own encrypted key to the service server. You can see here in the seventh step. What client will do? It will send his encrypted key, its own encrypted key, to service server. The server decrypts the key and check the timestamp still valid or not. So with this service server, it will decrypt this encrypted key and it will check the timestamp, whether this timestamp is still valid or not. If it is valid, then this means the authentication is done. Successful authentication between client and service server. Okay, you can see in the 8th step, the client decrypts the ticket. If the keys are still valid, the communication is initiated between client and server. If the keys are still valid, if the timestamp is still there, then it can go for the communication. Once the timestamp expires, or once the session expires, then client cannot communicate with the server. Okay, so these are the steps, 8 steps, along with the diagram I have explained. These are the steps, or these are the working principle of Kerberos. Next is whether this Kerberos is symmetric or asymmetric. So the answer is both. It is capable of doing authentication in symmetric mode as well as in the asymmetric cryptography. Next, is Kerberos safe? Yes, absolutely it is safe. It is more secure than the other authentication protocol. Other authentication protocols are like password or like a user ID. So when compared to all these things, this Kerberos is more secure than the other authentication methods. So this is all about the introduction about Kerberos, what is the working principle of Kerberos and other things. So let us see the different versions of Kerberos. So Kerberos came with two versions. One is V4 version 4, another one is V5. So now we are talking about V4. So this V4 we are using for authentication server, and we are also using this V4 for authentication server and ticket granting server, TGS. AS, only for AS we are using, and we are using for both AS and TGS, authentication server as well as ticket granting server. So how we will use version 4, Kerberos version 4 for authentication server only, and for both authentication server and ticket granting server we are going to discuss in this slides. You can see here So as I told, different versions of the Kerberos protocol, version 4 and version 5. So we are concentrating on the version 4. So let us see how this Kerberos version 4 is used in authentication server only. So this is C is nothing but client here, V is nothing but the server, and AS is the authentication server. In the first step, client will send the request to the authentication server. So what it will send is IDC, that is nothing but ID of the client or ID of the user. PC, that is password of the C or password of the client. And then ID of the V, that is nothing but ID of the server. This all information will be sent from the client to authentication server in the first step. You can see here, C is client, AS is authentication server, IDC is the identifier of the user C, IDV is identifier of user B, and PC is the password. Okay. Next. In the second step, this AS will generate the ticket, and this ticket will be sent back to the client. You can see here, AS will send back something to the client. So what it is sending back? It is sending back the ticket. So it will generate the ticket, and that generated ticket, it will send back to the client. So what is there in the ticket? You can see this ticket. What it is? It has been sent by the authentication server to the client. What it contains is, it contains IDC that has been sent by the client itself. It contains ADC. ADC is nothing but the network address of C. Identity of the C, network address of the C. You can see here ADC, network address of the C. And then IDV, identification or identifier for the V. V is nothing but server here. All this information is encrypted with KV, where KV is nothing but the secret key. It is a secret key shared between AS and V. So KV is the secret key. You can see here, secret encryption key shared by AS and V. Shared by AS and V. That means this key will be known by AS as well as AS is nothing but authentication server, and V is nothing but our service server. Okay. Client don't know that. That means whether client can decrypt this ticket? No, not possible, because client doesn't know what is KV. KV is known by only authentication server as well as V. So client will not know. So hence client can't decrypt this ticket. This is not possible for the client. Even though it is received the ticket, it will not encrypt it. Next, in the third step, client will send that ticket, whatever it is received from the authentication server, it will send it to V, that is service server. Because client can't decrypt that ticket. Hence what it will do is, it will send that ticket to the service server. Along with that, it will send IDC. That means ID of the client. This ticket now, as we told that, or as we know, it is encrypted by KV. So here this ticket contains IDC, that is identifier of C, ADC, that is network address of C, and then the IDV, that is identifier of V. V is nothing but server. Now, because this V knows KV, we have the knowledge of the encryption key. So now V can decrypt this ticket. After decryption, it comes to know the identifier of C, the network address of C, as well as the identifier of V. So these are the three steps which will take place by using authentication server. Okay. So whatever I have explained is there in this slide. In the step 1, as I told, client will communicate with the AS, and what AS will do, all these things, whatever I have just now explained, that is there in this slide. So I will share this slide to you. You can read all these steps. So these are the 3 steps which I have explained just now. It is there in this slide. So what is the problem with the using authentication server only? What is the problem? Because in the next step we are using authentication server as well as ticket granting server. We are using ticket granting server because there are certain problems in the only authentication server. If we use only authentication server in the Kerberos protocol, we will come up with some problems. So that problems are, first problem is, under this scheme, a user would need new ticket for every different service. This is one of the very important drawback here. So whenever client wants the service from the service server, for each and every new service, he has to generate a new ticket. So again and again generating a new ticket for new service, it becomes clumsy, it becomes time consuming, complex. So this is one of the problems. Second one is, the password must be transmitted without encryption. In this scheme, the password is transmitted without encryption. So once the password is transmitted without encryption, that means hacker can hack the password, he can capture the catchword and he can use any services. Okay, so that is called as eavesdropper. Eavesdropper is nothing but the third party, the third person, non-authentication person. So these are the 2 problems here. To overcome these 2 problems, we have to, along with the authentication server, we have to use ticket granting server to overcome this problem. So how we will overcome this problem here? You can see here. So here we'll use once per user logon session. So as you can see here, first step, client will communicate with the authentication server. What he will communicate? He will communicate with IDC, that is identifier of the client, and IDTGS. IDTGS is nothing but identifier of ticket granting service. Identifier of ticket granting service. As you can see here, in the first step, C is communicating to ADS. What it is communicating? It is communicating IDC along with ID of TGS, ticket granting service, identifier of ticket granting service. And we know that AS, what is the job of AS? It will generate the ticket. Will generate the ticket, and that ticket will be sent back to the C. It will generate the ticket and it will send back to the C. So you can see here in the second step, ticket TGS is generated. Along with that, it will send KC. Okay, this ticket is encrypted by KC. You can see here E KC comma ticket TGS. That means this ticket TGS, this is encrypted by KC. So what is KC here? A key that is derived from user password. KC is the key that is derived from the user's password, because in the first step, the C will send IDC and ID of TGS. IDC is nothing but identification of C. So how this C is identified? It is identified by its username and password. Username and password. So what AS will do? AS will receive that username and password, and by using that password, it will generate a key that is called as KC. By using that password, it will generate a key that is called as KC, and then it will generate a ticket TGS, and this ticket TGS is encrypted by this KC and sent back to the client. I hope this is clear to all of you. You can see here, whatever I have explained just now, it is there in this slide. So you can see C to AS, what it will provide: IDC, PC, and ID of the V. So what is PC here? It is password which is sent by the user. Okay. Right. So in the third step, so this is for logon session as we have discussed. Step 1 and step 2, this is for logon. This is called as logon session. Users logon session. These two steps. Whatever I have explained, it is there in this slide. So please go through this slide. Next, in the third step, you can see this third and fourth step together, it is called as once per type of service. Once per type of service. So you can see in the third step what it will do. Client is sending the information to the TGS, ticket granting server. What it is sharing? It is sharing the IDC, IDV, that is identifier of the client, identifier of the server, V is nothing but server, and ticket TGS. Ticket TGS. So once this TGS receives this information, it will generate a ticket of V. Ticket V, and that ticket V will be sent back to the client. Sent back to the client. So what ticket TGS contains here? As I told, ticket TGS contains identifier of the client, network address of the client, ADC is network address of the client, ID of TGS which has been shared by client itself. Now look at this. This is very important here. It adds the timestamp and the lifetime for this timestamp. Just now we have discussed. Once this lifetime got expires, that means we can't communicate. Okay. Now you can see here, this whole data is encrypted by KTGS. That is the key which has been shared between only AS and TGS. This KTGS will know by only AS and TGS. Now you can see here, this KTGS, this ticket of TGS is received by client. Yes or no in the second step. Now you tell me, after looking at this ticket TGS, whether it is decrypted by client. Whether client will decrypt this because it is encrypted by this KTGS. Whether client will decrypt it? No. Because this key is shared between only AS and TGS. That means it has to be decrypted by either AS or TGS only. So hence what client will do? Client will not do anything. It will receive the ticket and it will share that ticket to TGS. In the third step you can see. In the third step, what client is sending? It is sending its identification and the identification of the server V and then ticket TGS. Why it is sending? Because it can't encrypt and it can't see the other things what is there in the ticket. So for that purpose it is sharing it to TGS. Now TGS will receive this ticket TGS and now it will decrypt it. After decrypting, what it will know? It will know that it is sent by the client C. Along with that, it will check the network address, ID TGS, its session lifetime and its session time and its lifetime. Next, it will also generate, this TGS will also generate one more ticket that is called as ticket V. Now, this ticket V, you can see here, it contains all the information like IDC, ADC, IDV, timestamp 2. Here it is timestamp 1 because now new ticket is generated, right? So new timestamp and new lifetime is added by TGS. So that is timestamp 2 and lifetime 2. Now you can see here, this is encrypted by KV. What is KV? The KV is the key that has been shared between the server and TGS. So this KV will know by the server or this TGS. Now we are sharing this this ticket V to client. Whether again client can decrypt it? No, again not possible. Hence what client will do? Again he will send that ticket V to this server V. Along with that, he will send his identification IDC along with that ticket V. You can see here in the fifth step. Now what server will do? Server will receive this ticket V and now it will decrypt that ticket. Okay, because KV is known to this server V. So it will decrypt and it will come to know IDC, ADC, IDV, timestamp 2 and lifetime 2. This is what happened in the fifth step. So the fifth step is called as once per service session. So this is once per type of service and fifth step is once per service session. So whatever I have explained is there now in this slide. Third step, fourth step. Okay. So now what server will do? Server will check lifetime and timestamp. Whether timestamp is there or not, or whether lifetime is expired. If it is there, if it is valid lifetime, if it is valid the timestamp, then server will give or provide the services to the client. So first it will authenticate this client by using the tickets. So where the ticket contains its identification, network address, by taking all this into consideration, it will authenticate the client. Once the authentication is done and once the timestamp is valid timestamp, then it will provide the service to the client. It will provide the service to the client. So this is what is explained here in this slide. So I request you to go through this slide. So what solution it provides? AS provides both client and TGS with the secret piece of information in a secure manner. Okay. So here also we have we provide certain solutions here. That solution is nothing but again. So there is a chance of, see, here also one problem is there. What is that problem? The problem is the ticket can be hacked by the attacker only. So okay, man in middle kind of attack. So here, because this ticket is sent back to the client here in the second step, here in the middle he can attack the ticket itself. The attacker can attack the ticket itself. So we should not want that attacker to attack that ticket and to have the information. So what we need to do for that? We have a solution here for that. That is, AS provides both client and TGS. Along with that, it has to provide a secret piece of information in a secure manner. So because this ticket can be attacked by the attacker and he can hack that ticket. So because of that, what we can provide this AS to the client, he can provide some secret piece of information. Along with the ticket, he has to provide secret piece of information in a secured manner. In a secured manner. So secret piece of information in a secured manner. Then client can prove its identity to the TGS by revealing secret information again in the secure manner. Okay. So when client will receive that secret piece of information, that secret piece of information it has to share to the TGS in a secure manner. Then client will get authentication. Otherwise, if the attacker here itself he attacks the ticket, he only can send the ticket to TGS. Then what TGS will think? TGS will think the attacker as a client, not this as a client. Okay, because he will share the ticket, right? So what TGS will do? Okay, this ticket is come from this person. That means this person is the authentication client. So that can happen here. So hence the solution is, we need to, along with the ticket, we need to send the piece of information, secure piece, small piece of information to the client in a secure manner. Then client will send that secure piece of information to the TGS. So whenever the piece of information is secured, if the attacker attacks that secured piece of information, he can't do anything with that. Okay, so TGS will receive that secured piece of information, small piece of information, then the client will get authenticated. So this is the solution that we can provide here for this kind of problems. An efficient way to accomplish this is to use encryption key as the secured information. Okay, because we need to send that piece of information in the secured manner, right? So for that purpose, we can use encryption key. And this is referred as session key in the Kerberos. This encryption key, that we are calling it as session key in the Kerberos. Next, we will see what is the Kerberos version 4 for the message exchange. This is the scenario of the Kerberos version 4 message exchange scenario. You can see here three things. One is user. So three-headed, as I said, three-headed dog. One is user. Another one is Kerberos. Kerberos contains authentication server, ticket granting server. Along with that, it contains the database where the all informations of the keys and other things will be stored. And then we have an application server or service server. You can see here how the message exchange takes place. So it takes place in the 6th step. First, user will communicate with the authentication server. Authentication server, what it will do? It will receive all the information like ID C, ID of the user. All these things will be received from the authentication server, and the authentication server will generate a ticket, and that is encrypted format, and that is sent back to the user. Now user, what he will do? He can't encrypt that ticket, so he will send it to TGS server. TGS server will encrypt that ticket, and it will generate his own ticket, and which will be sent back to the user. Again, that ticket, so that this tells you that this user is an authentication user, and whatever the ticket which is sent by the TGS, now he will send it to the application server. Because he can't encrypt it, he will send it to application server. Application server encrypt that particular ticket, and then once it will think that he is the authenticated client, it will send back the response back to the user, so that this user or client and server can communicate with each other. This is what happened in the message exchange scenario. You can see here, first step, as I told. So client is communicating with the AS. What information he is communicating? Identifier of the client, identification of the client, ID of the TGS. Along with that, he is sending the timestamp, TS1 timestamp. Then in the second step, application server is return back something to the client. What it is returning? It is returning the KC TGS, then ID of TGS, timestamp 2, because timestamp 1 is already used in the first step, then timestamp 2, then lifetime 2, then ticket TGS. All these are encrypted by KC. You can see here, all these things are encrypted by KC. What is KC here? KC, as we know already, it is derived from the user's password. How it is derived, everything I have explained in the previous slide. Next, what is there in the ticket TGS? This ticket TGS contains KC TGS, identifier of the client, network address of the client, identifier of the ticket granting server, timestamp 2, and lifetime of the 2. These all things are encrypted by KTGS. KTGS is nothing but the key that has been shared between the application server and TGS. That means this key will be known by only application server and the TGS server. Client will not know it. Even though the client has received this ticket, he can't encrypt it. Sorry, he can't decrypt it. Now, what is KC TGS? You can see here the green mark. That key is KC, TGS. KC, TGS is nothing but it is a session key. As we told just now, we have discussed, it is a session key for the client as well as the TGS. It is a session key for client as well as TGS. So these two steps are called as authentication service exchange to obtain ticket granting ticket, that is TGT. These two steps. Next, the third step and fourth step together is called as ticket granting service exchanging to obtain service granting ticket. So as we know that in the third step, see here, client can't decrypt that particular ticket. What he will do? He will send that ticket along with the identifier IDV and that ticket ticket TGS, and then authenticator C. All this information he will share it to TGS, that is ticket granting server. Once this information is received by ticket granting server, what he will do is, or what it will do is, it will decrypt that particular ticket. Ticket TGS will be decrypted, and it will come to know what it will come to know. It will come to know KC TGS, that is ticket grant session key of the client as well as the server. Then identifier of the client, network address of the client, identifier of TGS, that is ticket granting service, timestamp 2 and lifetime 2. All this will come to know by this TGS, and it also comes to know that he is the valid client or authenticated client. Now TGS will generate his own ticket, that is called as ticket V. What this ticket V contains? This ticket V contains KCV. KCV is nothing but this is a session key for the server and client. We have two session keys here. One is KCTGS. This is the session key for client and TGS, and KCV is the session key for client and server. You can see here. Along with that, it contains IDC, that is identifier of the C, network address of the C, that is network address of the client, ID of the server, TES4, that is timestamp 4 and lifetime 4. Where this authenticator C, what it contains? Authenticator C contains IDC, network address of C, and timestamp 3. This timestamp IDC and ADC is encrypted by KCTGS, that is the session key of client and ticket granting server. Now this is received by client. This ticket V is received by client. Again, he can't decrypt it because this ticket V is encrypted by KV. And what is KV here? This KV is the key that has been shared between only TGS and server V. So again, what client will do? He can't decrypt it. Hence, what he will do? Again, he will send that to server V in the fifth step. You can see here. In the fifth step, you can see he is sending the ticket as well as authenticator C to the V, that is your server, service server. So what is there in the ticket V? Already we know. It contains session key of client and server, identification of server, identification of the client, network address of the client, identification of server, timestamp 4 and lifetime 4. So now this server can decrypt this because it is encrypted by KV. Now KV is available with V, so he can decrypt it and he can check this this session key. He can check the identification of client, network address of the client, identification of server, timestamp and lifetime, and he will verify whether it is having valid lifetime and valid timestamp or not. Once it is valid, then the client can communicate with the server. The client can communicate with the server. This fifth and sixth step, it is called as client server authentication exchange to obtain service. Hope this is clear to all of you. So whatever I've explained is there. Please go to this. This is the summary of all that 6 steps. You can see here 1, 2, this is 3, this is 4, this is 5, and this is 6. So all this summary of this, how the message exchange takes place in the Kerberos, all this has been diagrammatically represented like this. And what happens in the each step, it is there in this slide. The explanation is there here, and also it has been explained in this diagram also. And same thing, it is represented as a state diagram here. So this is the first step, second step, first, second, third step, fourth step, fifth step, sixth step. Okay, it is represented in a state diagram. Next, Kerberos realm and inter-realm authentication. So this comes under version 5. Kerberos realm and inter-realm authentication comes under version 5. So what is this Kerberos realm? It is a full service of Kerberos environment consists of Kerberos server, a number of clients, all are registered with the Kerberos server, a number of application servers, all are sharing keys with the Kerberos server. This whole environment together, we are calling it as Kerberos realm. So you can see here, n number of users are connected with the Kerberos server and n number of applications are connected with the Kerberos server. So what this application server will share its keys, secret keys will be shared between the application server and this Kerberos server. Next, these are the steps that will be followed here in the realm authentication. So we have 7 steps here. All these steps, whatever we have explained, all these steps are there here. So first, client is requesting to the authentication server. What authentication server will do? We know that it will generate a ticket. That ticket, local ticket, that sent back to the client. Again, client will send it to TGS server. TGS server will reply this to this client. Okay. Now here, see, this realm, this client which is present in this realm or this network wants to communicate with this TGS which is present in the another realm. Across the network it is taking place. Across the realms it is taking place. So how that communication is taking place, that is explained in all these steps. All these 7 steps. All these 7 steps. So in the first step, request ticket for local TGS. Client will request the ticket for local TGS. In the second step, this authentication will provide that local TGS ticket to the client. In the third step, this client will communicate with the local TGS. It will send that local TGS which is generated by AS. It will send it to TGS. TGS will decrypt that ticket and it will generate his own ticket, remote ticket, that will be shared to the client. So this remote ticket is means now this client can communicate with the other TGS which is present in the other ring. Okay, so you can see here. So client is talking to TGS remote. TGS remote is nothing but the TGS which is not local, which is present in other ring. You can see here in the fifth step. And now this TGS again it will communicating again it is generating his ticket and it is sharing back it to client. And then once client got that ticket, it can send that ticket to the server which is present in the another ring. So now client can request or the server can provide any service to this client. Okay, so all these steps are here and we know what is there, what is KDC, what is KC, TGS, all these things I have explained in the previous explanation only. So this is all about the Kerberos, different versions of Kerberos, working principles of Kerberos and other things. I request all of you to read the book carefully, okay, and understand the concept. Thank you.